In this video, we will start the process of transferring all the Roku base and remote control data to Blender, so then we can create the rendering and rebuild this product presentation. Again, as a repetition, if you want to export the design inside Fusion, you can go to the individual files you want to export, click on the version number, then click on View Details, and that then will online open the preview. And once this is loaded, just in a second, come on, Amazon servers, chop chop, time is running, tick-tock. Then we can export it as OBJ. And when the process is being done, we will get an email so we can download the file. And the nice thing again, by downloading this as an OBJ, we get the mesh, including all the material definitions associated to certain parts of the mesh. Before I continue, I would like to take a moment again to stress the importance of structuring your project folders. So what this means is, here I have one folder, Mac and PC, exactly the same. I just simply call this Roku project. Inside there, here I have my Roku body. I could also say base OBJ. I have a folder with render targets. Those are my inspirational images. And I have one folder where I put in all the textures I will use. So when at one point you want to copy and paste and move your Blender stuff, let's say from a jump drive to the university computer, and then from there back to a jump drive onto your home computer, you don't just copy a particular file, you just move the whole project folder. That's very important to do that. Okay, with that said, let's fire up Blender. Then we can go to File, Import, Wavefront OBJ. Go to Desktop. I have here my Roku project folder, and there's the Roku base. I want to set this one up to Z. So when I import it and I zoom out, the object is horizontally, and meaning the Z is up. Now I will undo this step and show you what happens when you imported this with Y up. This only means that basically the object is imported, just Y is up. So it's flipped. To fix this, it's pretty easy. There are multiple ways. I can click this object, I can click this object. So with the left mouse button, I click, hold shift, select the next object. And we see here the red line. That's the axis along I want to rotate my object. And we know here by red, that tells us it is X. So we can press R for rotate. We can press X for the X-axis. You see now it only rotates around the X-axis. And when I move this horizontally and I pay attention to the upper left corner, it tells me that's negative 90 in this case. So minus 90, enter, there we're done. Secondary way how to do this is we press N to open the transform palette. And then here we simply set this to 0. And then, whoa, what happened? Only this one object got changed, not the other one. So I could select this one, set this to 0, there. And in case you want to do both at the same time, you have to hold the Alt, or Mac also calls this Option key. So hold the key, click and drag X to Z, release the mouse button, release the Alt key, type in 0, enter, and now you see it adjusted everything at the same time in both objects. Very good. The scale is too big. So currently the space is 2 meters tall. That's quite big. I could walk into this. We have to adjust the scale. Here again, I can adjust object by object. Or I simply click the label, click the base, holding Shift obviously, hold the Alt key, click and drag, .001, enter, and 1.6 height. Let's double check actually with Fusion. Is that correct? Let's go to here. What's maybe the distance? Let's say, what's the distance between this face and this face? 19 millimeters. So that's, for example, not 100% correct. And this is 9.6. So let's go back to Fusion and do another scan here and say measure this edge to this edge. And this tells me the result is 105 millimeters. So go back to here and then we see, oh, this actually 001 is not 100% correct. We scaled this object a little bit too small. So how do we fix this? Well, it's pretty easy. I can click this one, then hold Shift, click this one. And then simply press S to scale until, what did we say, 105 for 105.9. Okay. Yeah, 105. Yep, kind of what we have. Okay, so that's pretty close. Now, if we want to be very precise, the secondary option is, because this is a rounded object, this might be a little bit tricky to measure correctly. So we create ourselves a small reference object. So this is 50 by 50 by 10. Very good. And now I only want to export that cube. So this cube I could click Save as STL and go OK. Let's say cube scale reference. And this trick I'm showing you right now is literally a trick that works not only Fusion to Blender, that works among all programs. Because sometimes when you export mesh objects, scale is always an issue to establish accurately. So I copied that OBJ object, sorry, the STL object into that folder. Let's go back to Blender. I will, in this case now, reset the value here to 1. So it has the original scale. And then I will import that STL cube. There it is. Z up. Okay, import. There we have it. So 50/50 by 10. Oh, that's interesting. So maybe actually the Fusion dimension wasn't correct, because if I set this to .001, yeah, that's exactly the way how it has to be. So which means if we type in 001 for the rendering purpose, then that's correct. To zoom into our object, view frame selected with something selected. There we are. Okay, so very good. That established the scale. Again, for the rendering, keep in mind if in the rendering we are off by 1, 2, 3 millimeters scale-wise, it really doesn't matter because all we do is just make a rendering. The For manufacturing or for 3D printing, we send the stuff out from Fusion to the 3D software. So keep that in mind. The main reason why we want the scale to be close is simply the way how lights work. It's based on physical reality. So if we have a really big object and the lights are tiny, it doesn't illuminate it correctly. So this means we just have to be close. Okay, so that established the first part, how to bring everything over from Fusion to Blender. And for Eric's Scrabble, here is a zip, zip, and kaboom!